Hello. Hello, everyone. You should be able to hear me. Mhm. I've got some exciting new stuff for you today. I've just published the assignment, so please have a look. Can you see the assignment? The new maths assignment. Can you check, please? You can't see me. Is that a problem with everyone? Can people see me? People can see me, so try exiting and coming back in. Have you? You can't hear me. Okay. Mhm. So what do you, have you seen the new assignment? Yes or no, please. Okay. Oh, yes. You can see you've seen the new assignment. Excellent. Okay, so it is accessible. Here's a link. I'll post a link, and you can open the assignment right now if you haven't seen it yet. So it's due on the 18th of February, and some exciting stuff. A lot of it, I hope, a lot of it will be easy for you, and some of it is quite unusual. So we try to make a mixture of that stuff. Do try the start questions. The start questions are my favorite, and I will be going through very similar questions today. Okay. So without any further ado, let's start. So I'm going to share my screen. You should be able to see my screen. If not, let me know. So the first problem is substitution. So solving equations. This is by substitution. By substitution. What do we see here? Well, we see an interesting thing. If we replace, if we let t equal 2x minus 1 squared, no, imaginary numbers are not in this course. Okay, so we don't do imaginary numbers at all. So no. Instead of saying that, you can if you wish. I'm happy for you to do so. If you want to, that's fine. But we assume we are doing only real numbers. But yeah, if you say a is less than 0 and it's yeah, I mean that's fine. Yeah, that's fine to explore. It's always a bonus. Okay, let t is this, then t squared is this. T squared is the same thing, 2x minus 1 to the power 4. And the equation becomes very simple. The equation becomes the equation becomes t squared minus t minus 12 equals 0. Right. So this is the equation. So we can solve it. Solve it by factorizing, for example. So it's good. T minus 4, t plus 3 equals 0. So that means t equals 4 or t equals minus 3. No, but we need to reverse substitution. Substitute. So t is 4, but t is 2x minus 1 squared. So 2x minus 1 squared is 4. And here we have 2x minus 1 squared equals minus 3. So 2x minus 1 squared equals 4. Well, you can, how would you solve that? How would you solve 2x minus 1 squared equals 4? Ooh, Dennis. Yes, very, very good. Square root both sides. Well, you could square root both sides. Well, technically, yes, you could. Very good. So you have two options. You have either 2x minus 1 is equal to 2, or 2x minus 1 is equal to minus 2. Therefore, you have 2x equals 3, x equals 3 on 2, 3 over 2. That's the first solution. Here you have 2x equals minus 1. So x is equal to minus 1/2. So that's x2. What about this one? You could expand and solve, yes. If you expand and solve, you get the same solution. So if you were to do if you were to expand and solve, it would be 4x squared minus 4x plus 1 equals 4. So 4x squared minus 4x minus 3 equals 0. And then you solve it, and x1 is going to be 3 over 2, and x2 is going to be minus 1/2. You could certainly do that. What about this one? So this is alternatively. What about this one? So Deshita has an interesting point of view that is it extraneous solution. Well, I wouldn't call it an extraneous solution, but it is well, it has no solutions basically. It's not a solution technically, but yeah, it makes no sense because a square number cannot be minus 3. Makes no sense. No sense. As something squared is not equal to minus 3, never. Therefore, the answer is simple. X belongs to the empty set. In other words, there are no solutions. So this is just a short way of writing no solutions. X belongs to an empty set. Solutions. Okay. If we expand, we get the same result, of course, because if we expand, we get 4x squared minus 4x plus 1 equals minus 3. So 4x squared minus 4x plus 4 equals 0. Divide by 4, so x squared minus x plus 1 equals 0. And if you try to solve that, so x is equal to minus 1 plus minus square root of minus, well, 1 minus 4. 1 minus 4, and 1 minus 4 is minus 3. So no solutions. solution as square root of -3 is not a real number. Okay, so that's about it. How well do you understand this problem? How do you understand the solution? So 10 on the scale of 0 to 10. Okay, tens. Oh, it's quite a few of you today. 10 people. 10 people. I've got 10 tens. What are the other 5 of you? Okay, the other 4 of you. Don't be shy. Come on. Okay, fine. Do you not understand something? Hopefully you are still here listening. Okay. A slightly harder one, but this is also done by substitution. What do you think the substitution is? It's not easy to type it. I'd rather you just shout out. What substitution would you use here? Four x minus 3 sub to a letter. Perhaps. So, but okay. There is a interesting point of view. There is one thing, one fundamental thing you need to know about substitution. If you are doing a substitution, it has to be a full substitution. A substitution is only acceptable when it's full. Therefore, x squared minus 2x over a plus 5 equals 16x minus 12 over 2x minus x squared is not a valid substitution. Not a valid substitution. As you should not have x left. Ooh, very good, Bishop. Almost, but there is a problem. They're not identical. The fraction, yes, that is correct. The whole fraction we substitute by t. So we say t is equal to this whole thing. Is x squared minus 2x divided by 4x minus 3. Now this thing doesn't look like this, but we can tweak it a little bit. We can tweak it and say, oh, let's take 4 out. And it's going to be 4, open bracket, 4x minus 3. On the bottom, it also doesn't look like x squared minus 2x, but what I can do is I can take the minus out. I can take minus 1, and in the bracket, the signs change. So I have x squared minus 2x. All right, so I've taken minus out, and I'm left with x squared. And now you can see that this fraction looks very much like this fraction, or of course upside down. So I've done the substitution. What I do now, so I can continue with the substitution. So it's going to be the equation. This equation becomes t plus 5 equals 4 divided by minus t. Almost there, Vishaka. Yes, minus. Yes, you're almost right. Yes, now you have this equation. Now you multiply everything by t, and you get t squared plus 5t equals minus 4. So t squared plus 5t plus 4 equals 0. And if you remember, at the beginning of the year, I showed you a trick that if a plus b plus c is equal to 0, then x1 is 1, x2 is c over a, or if a minus b plus c equals 0, which is the case, then x1 equals minus 1 and x2 is equal to minus c over a. Here we have 1. The coefficients are 1, 5, and 4. So 1 minus 5 plus 4 is equal to 0. Therefore, t1 is equal to minus 1, and t2 is equal to minus 4. So this is the trick of solving equations. But if you don't understand the trick, or you prefer not to use it, then it's fine. You can just solve it by factorizing. Okay, so we have the solutions. T1 equals minus 1 and t2 equals minus 4. And now we go back to the original. So that means x squared minus 2x divided by 4x minus 3. Why is it minus 5? Because I'm swapping. It's case 1 and case 2. For us, it's the second case. If we replace plus with a minus, then do you remember this method? Yes or no? Do you remember this method of solving quadratic equations? Please let me know, yes or no. You don't recognize it? No? Okay. Let me spend a few minutes just reminding you. You have two special cases. Special case. Case 1. If you have a plus b plus c equals 0. So example, if you have 3x squared minus 7x plus 4 equals 0. So it's a special case number 1 because 3 minus 7 plus 4 is 0. Therefore, the first solution is 1 and the second solution is c over a, which is 4 over 3, which is 4/3. So if you see a quadratic equation like this, the solution is 1 and 4/3. And you would be amazed how often you see those equations. Okay, does this make sense now? And those who said not really, okay. And special case 2, special case 2 is when you have a minus b plus c equals 0. So if you have, for example, 3x squared plus 7x plus 4 equals 0. So this is not special case 1 because 3 plus 7 plus 4 is not 0. But 3 minus 7 plus 4 is 0. Therefore, the first solution is minus 1, and the second solution is minus 4 over 3. And you can check that these solutions are true. So if you have an equation, and we had the equation t squared, we had t squared plus 5t plus 4 is 0. I can see that 1 minus 5 plus 4 is 0. So it's a special case 2. Therefore, we have t1 is minus 1, t2 is minus 4 over 1, which is minus 1. Okay, and does that make sense? Perfect. Lovely. Okay, so we have x squared minus 2x over 4x minus 3, and that's equal to negative 1. Negative 1. Or we have x squared minus 2x over 4x minus 3 equals to negative 4. So these are two separate equations, and all we need is, well, here we just multiply this by 4x minus 3, so it's x squared minus 2x minus 4 equals minus 4x plus 3. So x squared plus 2x minus 3 equals 0. Or x squared minus 2x equals minus 16x plus 12. X squared minus 14x plus 14x minus 12 equals 0. Can somebody see special case number 1? Yeah, special case. Case 1. So 1 plus 2 plus 3, 1 plus 2 minus 3 equals 0. That means x1 is 1 and x2 is minus 3. So solving quadratic equations gets really easy. Here, well, it looks like we'll need to use the formula because I don't think we can factorize it. Yeah, we can't factorize it. So I'm gonna use completing the square by completing the square. It might not be the easiest way, but I like it the best. X squared plus 14x. So it's a 7, so it's plus 49. That's a complete square. Minus 49 minus 12 equals 0. So what I did here, so I added 49 because that would make it a complete square. Then I did minus 49 because 49 minus 49 is 0. And then minus 12. And then this is x plus 7 squared. Minus 49 and 12, that's what, 61? Is it? It should be, yeah, okay, equals 0. So x plus 7 squared is equal to 61. That means x is equal to, so x plus 7 is plus or minus square root of 61. So x is minus 7 plus minus root 61. And this is x3 and x4. Now we only need to check whether these make sense. X equals 1. So we substitute back into the original one. And it should. Minus 3. No objection against minus 3. So yeah, both all of them are fine. I mean, okay, I'm using shortcuts here, but you can substitute them back into the original equation to check that they are solutions. That's called a sanity check. Okay, so we have 2 problems. We've done 2 problems. Now the next one. Sorry, I misheard how you get from the end part of the first equation to minus 4 over t, and I don't understand it. That's fine. Let's have a look. And that is the most important part. So thank you for asking. I notice. Oh, I notice. Actually, you know what? I'll go. This is a the essence. The essence. Okay, so you will notice that these fractions look fairly similar. So what I'm going to do with the second fraction, I'm going to take the 4 out, and it becomes 4x minus 3. And on the bottom, I'm going to take minus out, so it becomes x squared minus 2x. If I take a minus out, I change the signs automatically. So, and you can, and if this fraction is t, then this fraction is 1 over t. So it's technically, it's 4 divided by minus 1, okay, minus 1, multiplied by 1 over t, because that's the upside down fraction. And that means, well, it's 4 minus 4 over t. Does that make sense? No? Mark? Okay. So it's t plus 5 equals minus 4 over t. And that is the essence of this problem. That's the hardest part of this problem. It's not the hardest in terms of working out, but it's the hardest part in realizing that's what you need to do. Okay. Problem 3. 2 to the power x plus x equals 264. Any idea how to do that? It is logs. Ooh. Well, I'm not expecting you to use logs in at this stage. Solve graphically. Graphically. So what I'm going to do is I'm going to break it down. I'm going to go 2 to the power x is equal to minus x plus 264. And I'm going to draw two graphs. Draw two graphs. Y equals 2 to the power x, and y equals minus x plus 264. So this is basically a graph of the left-hand side and a graph of the right-hand side. Vishaka, I've spoken about the minus 4 over t part twice. You can watch the recording later on if you, yeah. Okay, so draw the graph. So y equals 2 to the power x, and you can draw it just like point by point, because you can use trial and error, yes. The problem with trial and error, like, okay, I understand, yes, trial and error will give you a solution. But how do you prove that it's the only one? How do you know that there are no other solutions? For example, if I give you x squared equals x, by trial and error, you can work out that x equals 0. But what about the other solution, that x equals 1? How do you know that there's only... If you use trial and error, how do you know that there are no more solutions that you've missed? And that's why graphical solving is a better tool than trial and error, or trial and error plus graphical. So we'll draw two graphs. So you draw the two graphs, and if you draw this graph, you say, so if x is 0, y equals 1. If it's 1, it's 2. If it's 2, it's 4. If it's 3, it's 8. If it's minus 1, it's 1/2. So you can see that the graph y equals 2x looks like this. Y equals 2 to the power x. The graph looks like this. And the graph y equals minus x plus 264 is a straight line, which goes something like this. Now, if you look at these graphs, you will understand that there can only be one point of intersection. We call this a monotonic graph. So y equals 2x is an monotonic increasing graph. That means simply, that means that it always goes up. So AKA always goes up. Goes up. And y equals minus x plus 264 is a monotonic decreasing graph. Decreasing graph. So AKA always goes down. Goes down. How well do you understand what I mean when I say it always goes up and it always goes down? Do you understand what I'm talking about? Please let me know. I'm happy to go through it again. So always goes up like this, yeah? So the y equals 2x, 2 to the power x always goes up, and the other one always goes down. So if they meet, they can only meet once. They can only be one solution, because they can only meet once. They only meet once. They can only meet once. And you can find that solution. It's x equals 8 by trial and error. By trial and error, x equals 8 is the only solution. You see how we've taken an equation. You don't need to do anything. You just need to guess a solution, but you need to prove that it's the only one. And of course, if we draw it, so actually, you know what? Y equals 2 to the power of x. So here's the graph. Okay, that's the graph of 2 to the power x. And y is equal to minus x plus 264. Is it? 264, yeah, that is it. And we zoom out. And here are the two graphs, one graph and the other one. And you can see that they meet at a point. The two graphs meet. The two graphs intersect when x equals 8. That's important. That's how you do graphical solving. Okay. Yeah, happy with that? The second graph, cos x plus x over 120 equals 1. There are no traditional methods that will allow you to solve this. There's no algebraic method that will give you the solution. Yeah, no algebraic method will give you the solution. But the graphical method, like, okay, in the assignment we have this, for example. We have this. We have a quadratic equation solved graphically. X squared is equal to 2x plus 3. Well, that's easy because it's x squared, that's the parabola, and y equals 2x plus 3 is a straight line. And so when they cross, that's the solution. So x equals -1 and x equals 3. But of course, you can just solve a quadratic equation because it's a quadratic equation. And the new assignment is posted. Nope, that's not it. It's on the website. Well, it's on, I mean, it's on Canvas, of course. Are you on Canvas, Eleanor? Okay, so it is on Canvas. But here's a link just in case. It's a quadratic equation. We can solve it graphically, yes. And the solution is -1 and 3. However, some equations we can't solve using algebra, but we can using the graphical method. So what I'm going to do here is I write down cos x equals minus x over 120 plus 1. And I'm going to draw the graph. So I'm going to draw y equals cos x and y equals minus x over 120 plus 1. I'm going to draw the two graphs. And I know that this graph is like this. So this is y equals cos x. This is 90. This is 180. And this graph minus x over 120 plus 1 is going through here. And, well, it's going to be a graph like this. Wow. Sorry, I think I've messed up dramatically. Uh, Let me just check. Well, anyway, we have we have a graph. We have two graphs. They intersect. It just turns out that they intersect many times. That's the problem that I'm having right at the moment. You'll see that they intersect in multiple points, something like this. But we can find 60. That's one of the solutions. This is 0. How do we know it's 60? Well, you can use trial and error, or you can just draw an accurate graph and you will see that the solution is 60. So let me just open this up. So y is cos x. Now you can see that this is wrong. This is because this is not in degrees. This is in radians. So you have to switch to degrees. And now it becomes a straight line. So you change the settings, the x-axis from minus 180 to, let's say, 600. Okay, now it looks more like it. So 180 is where is the bottom part. Yes, these kind of problems certainly come at A levels. And then you have y equals minus x over 120 plus 1. So you can see 3 points of intersection, 0, 60, and 216.8483. I was not anticipating this, so apologies. That wasn't planned. But I was sure that there's only one solution. But now drawing it, I realized that there are 3. So the answer, x is 0, x is 60, and x3 is 216.483 degrees. You can use Desmos to help you, yes. But I don't want your solution to rely on Desmos. So you won't have anything like that. This is harder than the ones in the assignment. In the assignment, it's actually much easier. You can use Desmos, but don't rely on it you can't say, oh, this is like this because Desmos, right? So, but yes, do use Desmos to help you. But this is fundamentally, you need to appreciate that this is a super powerful tool to solving equations. How to solve any equation? how to solve any equation. How to solve any equation. Well, let's take a difficult equation. Square root of 4 plus square root of x plus 7x plus 9, 7x squared plus 7x plus 9, plus a logarithm of x plus 7. I don't know why 7 comes up again, but anyway, equal minus 1/2 e to the power x. I don't know. Okay, I've run out of food. So a difficult equation. How do you do it? Well, you just draw. You just draw the left-hand side. So you say you draw this. So y equals this, and y equals this. Of course, you'll need technology to draw it because who in their right mind? Well, people did. You used to do that. So you just draw the both equations. So y is equal to square root of 4 plus square root x squared plus 7x plus 9 plus logarithm, what was it? X plus 7, x plus 7. So it's a graph. It has a gap. Never mind, that's fine. Graphs don't always exist. Okay, and then the other one was y is equal to, what was it? Minus 1/2 e to the power x. Y is, oh, minus 0.5 e to the power x. And you can see the two graphs and where they intersect. The answer is x is minus. So I really want you to appreciate the method. And this is how you solve some difficult equations in A levels. So in A levels, you are expected to use a graphical calculator, like this one. And it allows you to draw a graph, and it will show you the points. I don't know. Yeah, so the answer is x is minus 6.928. Now, I just remind you that all our equations at COMPOS, all equations, all answers should be given in exact form for maths at least. Okay. The next thing is an equation with a parameter. For what values of a does the equation have only one root? For what values of a does the equation have only one root? Well, first of all, we notice that it's a quadratic equation. E is a, oh yes, Vishaka, E is a number. It's 2.1, 2.2 2.71828, etc. It's a number similar to pi. It has a different meaning, but it's just as important in maths. Sometimes it's called referred to as Euler's number, but it's not the Euler's number. It's a mistake to call it that. Just E. And yes, Euler did a lot with that number, but it's not Euler's number. Okay, so it's a quadratic equation. It has only one root if the discriminant is 0. Yeah, so you can see that A is A, B is minus A plus 1, and C is 2A minus 1. So it's a quadratic equation with these coefficients. Coefficients contain A. And this is called an equation with a parameter, and the parameter is A. Equation with a parameter. And we know that it has only one root when the discriminant is 0, or it's not a quadratic. So when is this equation not a quadratic? I'll explain where E came from if I have a minute. Okay, if I have a spare minute. When is this equation not a quadratic equation? It's not a quadratic equation when... No, if the square root is negative, it's still a quadratic equation. It's a quadratic equation with no solution. But if A, yes, Vishaka, if A is 0, it's not a quadratic equation. Because if A is 0, this becomes a linear equation. If A is 0, it's not a quadratic. So let's look at A is 0. If A is 0, this is going to be 0x squared minus 0 plus 1 x plus 2 times 0 minus 1 equals 0. So that is minus x minus 1 equals 0. X equals minus 1. So only one solution. Only one solution. Okay. And discriminant is 0. That means d squared. So b squared minus 4ac. That is minus a plus 1 squared minus 4 multiplied by a multiplied by c, which is 2a minus 1. And that's equal to a squared plus 2a plus 1 minus 8a squared. Really? Minus 8a squared plus 4a. And that's equal to minus 7a squared plus 6a plus 1. And that has to equal to 0. All right, and somebody tell me what this is? What is this? What am I looking at? What's so special about it? Yes, it's special case 1. Special case 1. So A is either 1 or A is 1 over minus 7, which is minus 1/7. 2. and 3, A3 is 0. So the equation has one solution in 3 cases. If A is 1, if A is minus 1/7, and if A is 0. Okay. Right. But since we've been talking about the graphical method, of course, we have to use the graphical method here as well. Well, of course, we can use the graphical method here as well. And Desmos is a superb tool for that, because Desmos can do magic. Ax squared minus a minus 1 x plus 2a minus 1 equals, okay, that's y equals that. It doesn't show up anything because, but it does show add slider. It allows you to add the slider. And that means as you change the parameter, you can is it a plus 1? Okay, a plus 1. As you change a, the parabola changes. Okay. The second graph, now the second graph is y equals 0. Y equals 0. And that's a straight line. That's easy. So the question is, for what values of a do they have only one point of intersection? Okay, so a going, and we have minus 1/7, 1 and 0. So from minus 1 to 1. Oh, to 2. Step 1/7. So what is 1/7? 1/7, 0.142. 142. Okay. So no solutions, no point of intersection. So we have one point of intersection when a is 1. So good enough. Okay, so this is one point of intersection when a is 1. So this is a is equal to 1. And it's one point of intersection. The next one is a is equal to 0. And a is equal to 0, it's also one point of intersection. Because as you can see, it's not a quadratic, it is a straight line. So is a is equal to 0. One point of intersection. And finally, if a is minus 7, minus 1, 7. You can see there's also one point of intersection. Does that make sense? Does this question make sense to you? Anyone utterly confused? Somebody asked me what is E. I'll just E is defined. E by definition is the limit of n tends to infinity of 1 plus 1 over n to the power n. I won't go any further. That's the definition. Okay. Find the largest whole value of k such that the equation has no real roots. If it has no real roots, if the discriminant is negative. No real roots. If b squared minus 4ac, which is the discriminant, is less than 0. That means b squared, so b squared is 1, 1 squared minus 4 multiplied by 1 multiplied by c, which is minus k, is less than 0. So it's 1 plus 4k less than 0. So 4k is less than minus 1. K is less than minus a quarter. Find the largest whole value of k such that the equation has no real roots. So it must be minus 1. So the answer is k is equal to minus 1. Let's check. No real roots. So we do the same thing as we did before. We can drop this. Let's start. We need another one. So y is equal to x squared plus x minus k. Add slider for k. And y equals 0 in the second graph. So you can see here now they have two roots, but as we change k, we increase k, it's still two roots. And if we go the other way, so look, if k is minus 3, there's no roots. No intersections, that means no roots. If k is minus 2, no roots. Minus 1, no roots. 0, so minus 1, no roots. However, 0, yes, we have two roots. Therefore, this largest number is minus 1. So we can see that. Minus 1. So just literally minus 1. Minus 1. And minus 0. So If k equals -1, no roots. If k equals 0, 2 roots. Therefore, the answer is -1. Okay. Now, problem 7. It's a very unusual one. Do we want to start with something simpler? What about x minus 5 equals x minus 5? What is the solution? Does anyone know? How do you solve this equation? I mean, it's when you're solving an equation, what do you need to find? Don't be shy. Come on, ideas. I bet no one's ever given you this equation. So Parachita, yes, x, but you can be more specific. All the possible values of x. And Vishaka, you are correct. Any value of x works because, well, we can start like this. X equals 1 is a solution. X equals 2 is a solution, and all the numbers in between are also solutions. So the answer to this equation, well, I don't know about you, but when I was, it's not a trick. When I was your age, I found this incredibly difficult to understand, to comprehend. Like, how do we do that? So the solution is that x is any number. We could also write x belongs to the set from -infinity to +infinity, or we can say x is any real number. Anyway, the solution of this equation is any number, because any number works. What about this one? Is any that's a good question. I mean, you always define where you're working. You define x as a real number in the beginning of the question. So it is implied that x is real. So we're only talking about real numbers. So as I said before, we are only dealing with real numbers in COMPOS at this age level. Yes, because the way you find the way you do quadratic the way you do square rooted equations is you square both sides. You square both sides, and that becomes x minus 5 equals x minus 5, which is true for any real number. But you will quickly see that it only works when the square root of a positive number. You can't have x cannot be equal to 0, for example, because then you have square root of -5, which is impossible. So x the solution is x is any number as long as x is greater or equal to 5. So the answer, x is greater or equal to 5, and x is a real number. There's an alternative way of writing the same thing. You can say that x belongs to the set from 5 to plus infinity. That's another valid way of writing down the solution. And move this down. Okay. Now there are no tricks here. So here you just square both sides. Square both sides. And you get 2x squared minus 11x plus 13 equals x squared minus 6x plus 9. And then you solve the quadratic equation. Solve the quadratic equation. So x squared minus 5x plus 4 equals 0. And surprise, surprise, what is this? Special case 1. Yes, special case 1. I did not plan on these special cases. They just come up. And if you watch out for them, you will see how often they come up. It's incredible. Anyways, x is we need to test that they both make sense. So 1, if it's 1, so 2 minus 11 plus 13, it does make sense. Oh no, it doesn't, because 1 minus 3 is minus 2. You can't, it's the square root of something cannot be negative 2, so it doesn't make sense. X equals 4 makes sense on the other hand, so yeah. So not a solution. Not a solution. And this one is. The square root cannot be negative. You can't have square root of this cannot be negative. So square root of, so sanity check. Let's do a sanity check. Sanity check. Is square root of 2 minus 11 plus 13 equals 1 minus 3. So 2 plus 13, 15 minus 11, that's 4. Square root of 4 equals minus 2, which is not true. So minus 1 is not a solution, but 4 is. The way we define the square root, when you talk about the square root, so y equals square root of x is a function in the domain of the function. X has to be greater or equal to 0. And so the domain x is greater or equal to 0, and the range is y greater or equal to 0. If you draw the graph, y equals square root x, you can see that it has only positive values. So x and y can only take positive values. That comes from the definition. Because if we define the square, if we say that the square root can be negative, it opens a whole can of worms. So it's a matter of definition that I'm glad you asked, but you remember in school maths the square root cannot be negative, and well, generally the square root is not negative, except in complex numbers. Now this one, you would think that you need to square both sides and then square both sides again, because well, if you square both sides, you still don't get rid of the square roots. If you square both sides, it's going to be x square both sides. It's going to be x minus 5 plus double x minus 5 square root of 1 minus x plus 1 minus x equals 13. Because if you square, I hope you understand what I'm doing. So I'm squaring both sides, and it's not 13, it's 13 squared, of course. Then you take everything to one side, and then you square it again. So you get 2 square root of x minus 5 square root of 1 minus x equals 13 squared minus x minus 5 minus 1 minus x. And then you square again. Square both sides. Both sides. Again. And then you get something. However, let's analyze what we have here. This expression only makes sense if what? If x is greater or equal to 5. Thank you. And this part only sense if if 1 minus x is greater than 0, right? That means 1 is greater than x. That means x is less than or equal to 1. So this only makes sense if x is more than 5, and this only makes sense if x is less than 1. What do we have? What's the answer to the equation? No, yeah, there are no solutions. So this is the straightforward method, but here, actually, there are no solutions. In other words, x belongs to an empty set. Because there's no possible value of x that could fit. And let's we can draw that. I mean, square root. Well, we can't draw that because it won't draw it, because this graph doesn't exist. The left-hand side doesn't exist. Yeah, so that's it. It's not a graph with a hole, it's just nothing. Not even a graph. I wanted to talk about modulus a little bit. So the modulus. Now, it is believed to be a very complicated topic. However, if you understand modulus, you understand what it is, you understand the definition, then perhaps that would make your life easier. Definition of modulus. X, modulus x is equal to square bracket x if x is greater or equal to 0, or the square bracket means or, so I can mean putting or is a double kill, or it's equal to minus x if x is negative. So if x is positive, it's just x. And if x is negative, it's the opposite of that. So it's minus x. Does that make sense? Does the definition make sense? It's the absolute value, yes. But the way I've written the definition, does that make sense? Yes, modulus in computer science is different. Sorry, the Department of Maths has spoken to the Department of Computer Science and decided that what's the best way to confuse people? Well, let's use the same word for two different things. Yeah, it's called a modulo or division or just mod. Yes, mod is the remainder. That is true. Yeah, and well done for it's sometimes called modulus, yes. I'm modulo. Like if you say in Python, if you say modulus, you usually mean the remainder of division. Yes. Modulus x different from x. Well, modulus x is x if x is positive, and modulus x is minus x if x is negative. That's it. So basically what we have is we have two different equations. We need to look at two cases. This equation, so first case, if x is greater or equal to 0, then the equation is x squared minus 4x plus 3 equals 0. And second case, if x is less than 0, then it becomes x squared plus 4x plus 3 equals 0. So we say this opening the modulus, opening the absolute value, and we use this rule. So if it's positive, we just leave it as it is. If it's negative, then we put a minus. So we change the sign effectively. And this is of course a special case. x1 is 1, x2 is 3. We just need to make sure that it does not contradict this. There's no contradiction here, so both are valid answers. If x is less than 0, then x squared plus 4x plus 3 is 0. So then x3 is minus 1, and x4 is minus 3. And also no contradiction, so all values are valid. And if you draw the graph, you will see, so x squared squared minus 4 modulus x plus 3. And you can see the graph looks like this. And there are 4 points of intersection, -3, -1, 1, and 3. Okay. Right, and very quickly, finally, draw the set of points of the coordinate plane corresponding to this. So we have two moduli, and so we have 4 cases. Case 1 is so both of them are positive, x positive, y positive, and that becomes x plus y equals 4. Second case, if x is positive and y is negative, and it becomes x minus y equals 4. Now, if the third case, x is negative, y is positive, and this becomes minus x plus y equals 4. And finally, case number 4 is x less than 0, y is less than 0, and that's minus x minus y equals 4. And these are 4 graphs, and they are 4 straight lines. And if you were to draw them, I'm sorry I'm a bit rushing because I have to finish at 1:30. This is x, this is y. Now, if both of them are positive, that means we are in quadrant 1, we are here. X is positive and y is positive is here. Therefore, it's x plus y equals 4, so that's a graph that looks like this. So x plus y equals 4. And we're only within the limits, because if we go left, that's x less than 0 territory, so we can't go further than that line. And we can't go below that line because that's x less than 0 territory. The second, x is greater than 0, but y is less than 0. So that means we're in the bottom right quadrant. So x minus y equals 4. If you draw this graph, it looks like this. So this is x minus y equals 4. And if you do x less than 0, y positive, that's going to go like this. Minus x plus y equals 4. So that's 1, that's 2, that's 3, and that's 4. Of course, that will look like this. Minus x minus y equals 4. So it's a graph. This is a graph of this thing. It does resemble x squared plus y squared equals 4 squared. It does look something like that. Let's have a look. So modulus x plus modulus y equals 4. Aha, beautiful. Beautiful graph. And x squared plus y squared equals 4 squared. Looks like this. Well, what do you know? Publish that here. And hope this was useful for you. And I have to rush, and enjoy the assignment. And I'll see you next week. You're welcome. You're welcome. See you.
Bye.
Bye.